All right, so for our first one here, we've got an element, in this case a metal, reacting with an ionic compound to form an ionic compound in a different metal. That would be a single replacement reaction. That's 1 mark. Okay, written out in words. Okay, we're looking at sodium plus magnesium chloride. Gives us sodium chloride plus magnesium. No capital letters. 1 mark. Okay, then we got to balance the thing. So the only thing that's currently out of balance is chlorine. There's 2 on the reactant side. Now there's 2 on the product side, but that gives me 2 sodiums. So I have to go back over here and put a 2 there, and now that's balanced. Okay, so 1 mark for the balancing. Questions on number 1? Okay. For number 2, okay, we have an element reacting with another element to form a single compound. That would be what kind of reaction? Synthesis. Okay, 1 mark for synthesis. Okay, written out in words, calcium plus phosphorus gives us calcium phosphide. Okay, no capitals again, 1 mark. Okay, then we got to balance the whole thing. Phosphorus is already balanced. Okay, so that worked out pretty well. We got to go back over here though and balance the calcium. Okay, so 1 mark if they have a 3 in front of the calcium for the only balancing number required there. Did everyone do it that way? Did anyone notice I didn't swap and drop Ca3P incorrectly? Yeah. Okay. Did you fix it or did you just go with it? Okay. I didn't swap and drop this right. This should be Ca3. That's a 2+. So I must have just brought the number over. The brain fart on my part. That compound doesn't even exist. Okay. But we'll go with it because that's what I wrote. Okay. All right, lithium, so we got, sorry, for number 3 here, we got lithium hydroxide, ionic compound, calcium phosphate, ionic compound, producing 2 new ionic compounds. That would be, what kind of reaction? Double replacement for 1 mark. Okay, so written out in words, we've got lithium hydroxide, okay, plus calcium phosphate. Okay, gives us lithium phosphate plus calcium hydroxide. Okay, so for 1 mark. Okay, and then they got a balance. Hydroxide's currently out of balance over here. There's a 2 on this side. Okay, but if I put a 2 over here, that's going to mess it up. Okay, I've got lithium as a 3 over here. If I put a 3 over here, that's going to mess that up. But I do have the odd-even problem. Okay, agreed? There's an odd number of lithium over here. So what do I do to fix that? Double it, right? Okay, so how many lithium is that now? 6. All right, so I'm going to go over here and put a 6 in front of lithium. How many hydroxide does that give me? 6. So I got to put in front of this. 3. Okay, that gives me 3 calcium. That worked out pretty well because there's 3 calcium over here. 2 phosphates, okay, and this 2 means my phosphates are already balanced, so we're looking at 6, 1, 2, 3 for the balancing there. Questions on number 3? Okay. Excuse me. For number 4, okay, we have hydrogen sulfide reacts with strontium to produce hydrogen gas and strontium sulfide. So hydrogen sulfide is H2S. Okay, how do I know that? Well, this is -2, this is +1, so I drop and swap. Okay, reacts with strontium. Okay, Sr. And that's going to produce hydrogen gas, H2, and strontium sulfide. Strontium has a 2+ charge, so that should be good there. This is a -2, this is a +2, so those are dropped and swapped correctly. So give them a mark if they have that. They put the 2 where? Yes, it does. because it's not SR2S2, it's SRS. Yeah. Okay, what kind of reaction is this? Single replacement. Give them a mark for that. Okay, and then we've got to balance the thing. All right, hydrogen's 2, strontium is 1, sulfur is 1. It's already balanced. Okay, so if they put all 1s, okay, you can give them a mark. All right, if they had anything else, it's no good. Okay, for number 5, okay, we have C8H18. This is the active ingredient in gasoline, octane. Okay, reacting with oxygen gas, okay, to produce carbon dioxide and water. So if they have that, give them a mark. What kind of reaction is that? Combustion, right, so give them a mark for combustion. Okay, then we got to balance it. I have an even number of carbons, so I apply the rule of 2 and then balance alphabetically. So 2 times 8 is 16, so I need a 16 here. Okay, 2 times 18 is 36, so I need 18 here. All right, 16 times 2 is 32, and 18 more is 50. All right, so 25 times 50, or sorry, 25 times 2 is 50. Okay, so that's the balancing numbers. If we have those, give them their third mark. Okay, and lastly, number 6, potassium sulfide. That's, okay, this is -2, this is +1, so we're looking at K2S. Breaks down into potassium and sulfur. So if they have that, you can give them a mark, because sulfur is one of the special elements. What kind of reaction involves breaking down? Decomposition, give them a mark for that. Okay, then we got a balance, starting with the biggest number first. So an 8 goes over here, which gives me 16 potassiums. So we're looking at 8, 16, 1 for our balancing numbers. And give them a mark for that. So the whole thing's out of 18 marks. Please give them a mark at 18, write it on the top. Let them see it, and then once you've seen yours, please put it in the box. All right, yesterday we went over predicting the products of a chemical reaction. Okay, so I want to quickly review that with everybody because some of you weren't here when we did that. Hopefully you watched the podcast yesterday. Okay, if you didn't, well, you're a little behind the 8 ball, to be perfectly honest. Okay, but we'll go over, kind of review the steps here. If you also were not here yesterday, there are handouts in the 3rd drawer. Okay, there's 2 worksheets, and then there's a flow chart of how to predict chemical reactions. You need to grab those 3 sheets. They should be the worksheets on top and the flow chart underneath, or the other way around. All right, so quick review here. First step in predicting the products of a chemical reaction is, if the question is given to you written out in word form, the first step is you have to write the formulas. We're already at that step with these examples. We've already written the formulas for the reactants. Okay? The next step, once you have the reactants written down and any ionic compounds have been swapped and dropped and any special elements have had their special numbers put beside them, okay? Then we need to identify what type of reaction is going on, because every reaction is unique. Every reaction type is unique. Okay? And as a result, they have unique products, okay, which we can then predict because we know each reaction has a specific pattern. Okay? So if we're looking at number 1 here, okay, we've got potassium reacting with water. All right? And water is written as an ionic compound here, hydrogen hydroxide. Right? So if I have an element reacting with an ionic compound, I have what kind of reaction going on? Single replacement. Okay, in a single replacement reaction, okay, the lone element replaces the thing that is like it in the ionic compound. So right now, this is a metal. What's acting as a metal in hydrogen hydroxide? Hydrogen. Yeah, hydrogen is acting as a metal. It's the positively charged thing. Hydroxide is the non-metal. It's listed second. Okay, metals are always written first. All right, so if we're looking at that, okay, potassium then has to replace hydrogen, and hydrogen has to end up by itself. All right, so there, we've predicted our products. Okay, once we've done that, we now have an ionic compound that hasn't been swapped and dropped yet, and a lone element that may or may not be one of our special elements and require a small number. So these are things that we now have to check. Okay, potassium hydroxide. This is a -1, this is a +1, so is that compound okay the way it's written? All right, so we're done with that. Okay, hydrogen, special or not? It is. It comes as a 2. All right, so we write that in there. Now the products are right. Now what do I do with the whole reaction? I don't have to write it out in words, but what have I not done with it yet? I haven't balanced it yet. Okay, so now I balance the numbers. I've got 2 hydrogens over here, but I only have 1 on this side. Okay, so I've got to put a 2 there to balance the hydrogens. That gives me 2 hydroxides, so what needs to go here? A 2, okay, which gives me 2 potassium, so I've got to go back over here and put a 2. Okay, so we've got 2, 2, 2, 1 as our balancing numbers. Okay, single replacement are the toughest ones because you have the most things to check for. You're going to have an ionic compound that you'll have to swap and drop, and there's the possibility of a special element being by itself, so you'll have to check for those. Okay, most of the other reactions, there's not as many things to look for. All right, let's look at number 2 here. So we got copper sulfide. In this case, it's copper 1 sulfide. How do I know it's copper 1? Right, there's no little number with the S. S is -2. If I need 2 coppers to balance that, copper's charge had to be 1. Okay, so this is copper 1. It's important for me to know that because over here, copper's going to end up with who? With hydroxide, because this is a double replacement reaction. These are both ionic compounds, and in a double replacement reaction, we swap the metals. Okay, so copper has a new partner in hydroxide, and sodium has a new partner in sulfide. Okay, these are both ionic compounds. I have to do what always with ionic compounds? I have to drop and swap. Okay, now I figured out that copper over here was a +1, so it'll be the same over here. I can't change the kind of copper I have from one side of a reaction to the other. It stays the same. Okay, so this is copper 1, this is -1, so is that compound okay? All right, so it's good the way it's written. Okay, sodium is a +1, sulfide is a -2, so when we drop and swap, we're going to get Na2S. All right, now we're sure of all of our products. Now we balance the whole reaction. What should I start with? Highest number. So I could start with copper or sodium. Doesn't really matter which one I choose. Okay, I'll start with copper just because it was first. There's 2 of them over here. Now there's 2 of them over there. But that gives me how many hydroxides? 2. So I got to go back over here and put a 2. And that makes my sodium balance. So now the reaction is good. Okay, you guys kind of following me here? Right? So really, for those of you that weren't here yesterday, it's not all that different than what we were doing already, except you have to make up the products. Okay? But since all reactions have kind of a set pattern, it really isn't all that much more difficult. Okay? We should know who's going to end up with who. Okay, let's look at number 3 here. I have an element reacting with an element. What kind of a reaction is that? Synthesis reaction. What happens in a synthesis reaction? They're going to go together, right? They're going to make a single compound. So I'm going to have Fe goes with O. Now, is that an ionic compound? Yes, it is. So I need to drop and swap it. Here's the problem. Iron has more than one possible charge. And it was an element on the reactant side, so I have no way to figure out which charge it actually has. Agreed? Normally we look at it in a compound and we can figure out what its charge is. In this case, there's no way for us to do that. So if you look at your periodic table, look at iron on your periodic table. Okay, iron can be a 2 or it can be a 3. Which number is listed first? 2 is listed first on this one. Is it not listed first on yours? 3 is first on yours? Okay, on yours, 3 is listed first. 3 is the most common charge for iron. Okay, so that's the one we use. If you're ever in this situation where there's no way to tell, you just look at the first number that's listed. That's the most common charge. Okay? Actually, on this one, 3 is bolded. So that means it's the most common charge. This periodic table works a little differently. Okay? 3 is the most common charge for iron. So iron's a 3 plus, oxygen's a minus 2. So we're looking at Fe2O3. All right, I've swapped and dropped my products. There aren't any special elements to worry about. Okay, so now I got to balance the whole reaction. Okay, if I go over here and put a 2 in front of iron, am I going to be changing it? I am, right? Because I've got 2 oxygen and 3 oxygen, and that's not going to work. So I have the odd-even problem. What do I do to the odd side? Right, put a 2 there. All right, that gives me 6 oxygen, so what goes here? Okay, and what goes here? 4. Right. Okay. Right. We'll go through all of these together here just so that you see a few more done before we set to work on it. Okay, number 4. I have only one reactant, okay, and it is trinitrogen monophosphide. What's the only thing that can do? It can only decompose. Okay, it's not reacting with anything else. So in a decomposition reaction, what am I going to have for products? Right, the same elements, just separated. All right, so I'm going to have N and P by themselves. What do I need to check about N and P? Right, if they're special. I got to see if they're highlighted on my periodic table and require small numbers, and they both do. Okay, nitrogen comes as a 2, phosphorus comes as a 4. All right. So let's balance phosphorus first. Biggest number first always. So there's 4 over here. There's only 1 over here. So what needs to go in front of this? 4. Okay, how many nitrogens does that give me? 12. What times 2 will give me 12? 6. Okay, so there's, yes, lots of little things to remember. Okay, but once you kind of get those patterns set, okay, it becomes pretty straightforward. All right. See, we haven't done one like this yet. Okay, so for number 7, let's look at number 7 here. Okay, I've got C9, okay, H20 reacting with oxygen gas. What kind of reaction is that? Combustion. Combustion are probably the easiest because it doesn't matter how many carbons and hydrogens there are, the products are always what? Carbon dioxide and water. So you never really have to think much on those, okay? It's always going to be CO2 and water, okay, for a combustion reaction. Now, do I need to apply both special balancing rules to this one? No. 9 is an odd number, so I can go straight to balancing alphabetically. 9 carbons, okay, 20 hydrogens. 9 times 2 is 18, plus 10 more is 28. 14 times 2 is 28. Okay? Everybody all right with that? Okay, I'm going to give you a few minutes. I want you to try 5, 6, 7, 8, 9, and 10. Sorry, 5, 6, 8, 9, and 10. We already did 7. Okay, I'm going to give you a few minutes on those, then we'll go over those ones together. All right, let's have a look at these here. So for number 5, I've got calcium fluoride, which is an ionic compound, reacting with manganese 4 nitride, okay, which is also an ionic compound. So what kind of reaction are we looking at here? Double replacement. So in a double replacement, all I do is swap the metals so that they have new partners on the other side. All right? So that means calcium is going to end up with nitrogen. Manganese is going to end up with fluorine. All right. Now, if they're both ionic compounds, what do I have to do with both of them? I have to drop and swap. Okay, nitrogen's a -3, okay, and calcium is a +2, so we're going to be looking at Ca3N2 for our numbers on that one. Okay, manganese on this side was a +4, because nitrogen's a -3, that gives me 12 negatives. Okay, so +12 divided by 3 gives me +4 for manganese. Everyone okay with that? Okay, so manganese is a +4 over here as well. All right, so that's going to give me this, MnF4. Everyone okay with that so far? Okay, now I've got a balance. What's present in the largest number? Okay, yeah, nitrogen over here is a 4. Okay, so let's put what in front of this? 2. Okay, so we've got a 2 in front of that, which gives me 6 calcium. So I got to go back over here and put a 6 in front of this. Okay, that gives me 12 fluorine. So what needs to go in front of this? 3. Does that make my manganese work out on the other side? It does. So now the whole thing is balanced. Okay. Hey, for number 6, I've got lithium bromide, an ionic compound, reacting with phosphorus, which is a non-metal element. What kind of reaction is that? Single replacement, right? Okay, since phosphorus is a non-metal, who's it going to replace? Bromine, right? It has to replace the thing that's like it. So in this case, bromine's going to end up by itself. Phosphorus is going to wind up in a compound with lithium. All right, now we said, in a single replacement reaction, you have the most things to think about. You have an ionic compound that needs to be, what do I have to do with it? Drop and swap. Okay, phosphorus is a -3, and no, yes. Okay, it's a -3. Lithium's a +1, so we've got Li3P for our ionic compound. Is bromine special? Yes, it is. Comes as a 2. Okay, phosphorus, present in the largest number, so let's balance it first. What needs to go in front of lithium phosphide? 4. Okay, that gives me 12 lithium, so I got to go back over here and put a 12 in front of lithium bromide. That gives me 12 bromine, so what needs to go in front of this? A 6. Does that make sense, everybody? Okay. All right, for number 8, I've got cesium reacting with sulfur. Element plus element gives us what kind of reaction? Synthesis. All right, so in a synthesis reaction, these two need to go together. Need to go together in a compound. All right, it's an ionic compound, so this is -2 and this is +1. Okay, so we're going to have CS2S, okay, as our ionic compound over there. Now, balancing, I've got 8 sulfur over here. Now I have 8 sulfur over there and 16 cesium. Okay. All right, number 9. What kind of reaction is that? It's a double replacement. Okay, so in a double replacement reaction, zinc's new partner is going to be chlorine. Rubidium's new partner is going to be oxygen. Okay, so when we're balancing, this is when we're swapping and dropping, +2, -1, so we're looking at ZnCl2. This is a -2. This is a +1. Okay, so we're looking at Rb2O. All right, now I can balance the whole reaction. Looks to me like since these two are both 2s, a 2 here will solve all of my problems. Agreed? Yeah. Okay, questions on that one? Okay, last one. Carbon hydrogen containing compound, octane, which we did earlier, okay, reacts with oxygen, is a combustion reaction. Products are CO2 and water. Okay, like I say, we actually did this one. It was on the quiz this morning. Okay, so it's an even number. So we need a 2 in front of it. 2 times 8 is 16. Okay, 2 times 18 is 36. So the 18 goes there. 16 times 2 is 32. Plus 18 is 50. So 25 times 2 is 50. Okay, is this sort of making sense now? We're still going to be working on this on Thursday and Friday, most likely. Okay, tomorrow we're going to be doing a lab, which is why right now we're going to stop doing this and we're going to start the pre-lab stuff. Okay, everybody with me there?